Hello and welcome back to LIVENODING. In this episode, I will be trying this Edgenet To Path node of SVerchok add-on. So basically, I like to explore some of the SVerchok nodes in order to maybe use some of them actually inside geometry nodes, because SVerchok actually has hundreds of algorithms that can you make it so much easier if you are actually using a lot of procedural, and some of them can be converted into geometry nodes quite easily. Some maybe slightly tricky. Eventually, all the nodes can be available in geometry nodes, I guess. So with Edgenet To Path, so basically with Edgenet is you need to have a mesh composed by vertex and edges, and then this will turn it into some kind of path, some kind of curve. So if you have like this hexagon, it's gonna turn it into something a little bit like this, and it's gonna, each of the lines will be separated. Yeah, so the easiest example probably this one. This is the documentation from the nodes itself. So I'm just gonna show you. So SVerchok already installed. Once SVerchok installed, you can just use it. I'll delete everything. SVerchok. So Edgenet To Path. So let's start with a grid, for example, plain grid. Mesh viewer. Select this, shift select, and then V to connect it. Let's make the grid like 20 by 20. Turn on the wireframe. Save this very quickly. Edgenet. And yeah, let's connect this. 1, 2, 3. Select, tap V. Oh, something, yeah, the polygon doesn't connect. Let's disconnect that. So we're gonna end up with, okay, just a bunch of lines. Actually, it's being separated. And I believe it is actually quite random. So you can randomize where it's disconnect itself. Let's make this more interesting. Let's merge by distance. So 1, 2, 3. If we are merging, okay, let's before we connect it to this guy, let's see how it looks if we just merge. Yeah, okay, we're gonna get that kind of like a triangulated result. Let's increase the number of divisions. Okay, so that's the result. So let's use the Edgenet To Path once again. 1, 2, 3. It's giving an error. Let's disconnect the face. So we're gonna end up with these lines that's gonna get separated randomly. So that's the purpose. It's very easy to use, easy node, super easy node. And if we want to use it with geometry nodes, we use it with a polyline viewer node, because the output of this will be curve. Okay, that's what I want to show you. So we're gonna end up with a lot of mesh, or so this is mesh curve, right? Let's disconnect that. This one is a lot of lines, which is like a curve. So this is already kind of interesting. If you want, the output can be merged into a single object if you want to. So now we only have a single curve, and this one can be connected into geometry nodes if you want. So at this point we can, I know this is like in SVerchok you can use like random value, for example, right? Randomize the seed, can increase the number. If we use box, we can do the same thing. Box, connect there. So this is a box, right? You can see the lines there. Let's increase the subdivisions. Okay, we get this kind of interesting pattern. Merge by distance. Increase the subdivisions. 20 by 20 by 20. We can randomize the subdivisions. This is something that you can do inside geometry nodes. So if you want to bring this into geometry nodes, you simply turn off this bevel depth. So now this guy can use geometry nodes. Add geometry nodes. Go to geometry nodes. And since it is like this guy is a curve, right? Curve to mesh. Circle. Set curve radius. Oops. Set curve radius. Once it is a curve, it's actually kind of easy. It's supposed to be this simple. If you ever combine SVerchok and geometry nodes, and I kind of wish at some point we're gonna have AI that understands, okay, if we want to do this, okay, we have a mesh and we want to convert each mesh into a curve, which node we should use. Of course, you can dig into SVerchok. There's hundreds, 200, 300 or 400 nodes that you need to dig inside. The AI can understand the help, and then you can query that. So in this case, in geometry nodes, you can always resample and based on the length. So this gets interesting, right? You can fill the cap. Once you fill the cap, you can also turn it into volume and remesh it. It's beautiful, basically. It's really beautiful the way it can work together. Save as incrementally. I want to show another example very quickly. Yeah, this is using similar example, using similar nodes, which is the Edgenet. And somehow this might look slightly more complicated, but it's actually quite simple. Let me show you. Turn this on. If I jump to different frame, you will see it keeps changing automatically. That's so basically what's going on here. I will explain. There's a frame that goes into the seed at the moment. It's changing the positions and the size of the rectangle, and then extrusion, random extrusions, and then so there are two things going on. So first of all, I have a plane inside SVerchok, and then I use this combo to basically draw plane and then randomly place the plane. And in SVerchok you can actually do this. Just have a plane with a random size between these two numbers, make it 10. I only assign 10 frame. I can increase it to 20, so we can have more. Let's make it 10 for now. And also this one, place the plane on different place, so they are kind of overlapping. And then I join it into a single mesh. Use intersect edges, so they are of course need to be intersecting. And then once intersect, if we use intersect edges, whenever it's overlapping, it's gonna create a new vertices. Okay, and then we can use planar Edgenet, and then use inset special. Yeah, this is for extrusion actually. Inset special is actually can be used for extrusion, and then as a bonus you have inset can have inner on and off. Separate loose, this one is to separate some of the boxes. If they are separated, they have different color. The bottom part is not filled, that's okay. So that's one. This is the mesh part. The other one, actually, I'm using, I subdivided it and then use the Edgenet To Path and then randomly cut. So it's finding the polygon edges and then randomly cut it and then create this kind of pipe based on that. This one is randomizing the pipe thickness. We can actually do this in geometry nodes, but I'm just showing you. In SVerchok you can do that. You can also, you need to use list split to separate the value, but if you just plug this in there, we have random radius on every vertices, but if you use list split, it's gonna be randomized for each of the pipe. SVerchok is really cool in this way, you know, like because it works like list based. You can separate list and split it and join the split. You can use random value for the pipe, you see. Oh, this smooth line is special. This is to round the corner. This is also an interesting node to use. Geometry nodes does not have this yet, but someone could recreate smooth lines. And SVerchok add-ons has been around. It's like maybe 5 years before geometry nodes or even longer. But a lot of algorithm inside SVerchok. If you want to dig inside it, there are basically too many, and then we probably need AI to see inside it, or you need to read inside SVerchok GitHub. So every time, I remember during the development of SVerchok, every developer, whenever they create a new node, they will post it under issues. So we can always, you see this one, Victor Dolfral created these nodes before it's become part of SVerchok. So you can dig through. Yeah, there's a lot of example as well inside there. Okay, so that's pretty much it that I want to show you. So okay, this is the list masking stuff. It might seem slightly complicated, but no, not really. This is the masking. So from here, instead of just plugging the vertices and edges there, which is gonna create the lines from every edges, we can randomize the separations of edges using this setup. So this one just polygon to edges, because the output of this doesn't have edges. Or actually I can just, in this case I can plug this there. It's the same thing. Sometimes the output doesn't have edges. That's why we need this P to E. So this one only have like vertices and polygon face. So we use P to E to find the edges and subdivide it. Once it's subdivided, we can do merge by distance. Remember this vertices, edges, vertices. There. So this is the curve that's based on this guy, and we can we can combine both of them. If we wireframe this guy, that's the result. Maybe I should have plugged this guy into that guy. So we have this pipe worms that is originated from this mesh, and that's the power of the Edgenet to Path. It's actually, believe it or not, it's similar to geometry nodes, polygon to curve, and then if you can split the polygon randomly, you're gonna get actually it's a quite similar result. But it's good to know SVerchok actually does this as well. So hopefully you find this useful. Yeah, like I said, there are too many nodes in SVerchok. If you are ever curious, so if you find a node inside SVerchok and you want to know more about this, just find a documentation online, select the node, find documentation online, and you're gonna get some examples. Yeah, give it a try yourself. Hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.